Sets. A set is a collection of well-defined objects. Here are some collection of shapes, and mathematically we define them as polygons. So this belongs to the collection of polygons. Now we can further group them based on the number of sides. So we have those with 4 sides, then we also have those with 3 sides, with this and this. So this will form a set of parallelograms, and this also form a set of triangles. We use braces to list sets. Set notations. We use uppercase letters to denote sets. So for instance, we have A is equal to A, B, C. Then we could have another set also. B is equal to 1, 2. Then the members of the set are called the elements of the set, or the elements are the same as the members. So the elements of set A are A, B, and C, and the elements of set B are 1 and 2. Then we use this symbol to denote belongingness, that this is an element of or is a member of. So we can say that B belongs to set A, then 1 belongs to set B. 1 does not belong to set A. So this means does not belong to, or is not a member of. The empty set. Now we have a set that has no elements, and that is what we call the empty set. This is how we write it, or we use this symbol. It is also called the null set. The null set. So an example is a set of SHS students that sit for university exams. So SHS students sitting for university exams. We don't have any student from SHS that will be examined by lecturers. Another set could be set of teachers that write as WASI. Teachers that write WASI. We don't have any teacher that sits for WASI exams, so that set is empty. We have a number of them. Now the cardinality of a set is the number of elements in the set. So we had our first set A to have elements A, B, and C. Then we have another set B with elements 1 and 2. So the cardinality of set A, this is how we write it. Number of elements in A is equal to 1, 2, 3. So it's 3. Then the number of elements in set B is equal to 1, 2 is equal to 2. So this is the cardinality of the set, or the number of elements in the set. subset of a set. If we have a set A and another set B, then all the elements of A are also elements of B if A is a subset of B. So let's say we have a set A is equal to A, B. Then another set B is equal to A, B, C, D. Then A is a subset of B because the element A is here, the element B of A is also in B. Then this is the symbol for subset. So we can write this as A is a subset of B. We write it mathematically as A is a subset of B. Now the other way around will mean superset. So if you write it this way, then we say B is a superset of A. Every set is a subset of itself. From the definition of a subset, we say that if all elements of A are also elements of B, so all the elements of A are also elements of A. So set A is a subset of itself. A is a subset of A. Then also the null set is a subset of every set. So the null set is a subset of every set. It's a subset of A and at the same time a subset of B. Note that the null set is also written like this. So the null set is a subset of A, etc. Now we can list all the subsets of a given set. We can list all the subsets of a given set. So let's say we have the set A. So we have a set here. Set A is equal to the null set. Then the subset of A will be just the null set because it's a subset of itself. Then the number of subsets, let's say number of subset is number of subset. So the number of subsets over here is 1. Then we have another set B and it has only one element, 0. A set with a 0 element is different from a set without an element. So it has an element and that element is 0. 0 is an element. We are not saying the number of elements is 0. So B is equal to this. Then we have the subset R, the null set, then the set itself. Because this is found in this. And the empty set is also found in this. So the number of subsets is 2. Then also we have another set, say set C is equal to, let's say 0, 1. Then the subsets are, if we want to list all the subsets, we will have the null set, then the set with only 0 as an element, then the set with only 1 as an element, then the sets with both 0 and 1 as elements. That is the set itself. So we have 1, 2, 3, 4. This is the possible set we can list. The possible subsets we can list out of this. Then this will give us 4 subsets. So this is number of subsets. Number of subsets. Then we have set D with elements 1, 2, that is 0, 1, 2. So the subsets are, we have the empty set, then we have the set with 0 as element, then we have the set with only 1 as element, then we have the set with only 2 as element, then we have the set with 0 and 1 as element, so 0, 1, this set is a subset of this. Then we have the set with 0, 2 as element, then we have the set with 1 and 2 as element, then we have the set with all these as element. Now the set itself 0, 1, then 2. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 number of subsets. Now let's see whether we can establish some relationship over here or some pattern among the number of subsets. It's continuous. So these two, now all these are related to 2. 2 is related to 2, 4 is related to 2, 8 is also related to 2. So these two can be written as 2 raised to the power 0, and these two can be written as 2 raised to the power 1. Then the 4 can also be written as 2 raised to the power 2. Then 8 can be written as 2 raised to the power 3. So if we have a set, let's say set E with elements 0, 1, 2, 3. So this is having 4 elements. Without listing them, we can tell that the number of subsets will be 2 raised to the power 4. That is 2 raised to the power 1, 2, 3, 4. The number of elements. 2 raised to the power the number of elements will give us the number of subsets. So 2 raised to the power 3, because this is having 1, 2, 3. 2 raised to the power 2, 0, 1, and this is 1, 2. So then 2 raised to the power 1, this is 2 raised to the power 0, that is nothing in it. So the number of elements base 2 will give us the number of subsets. So in general, we have n elements, a set with n elements, then the number of subsets will be 2 raised to the power n. The universal set. The universal set is denoted by this symbol or this. So it's a set that contains all the elements under consideration. So if we have the set of the vowels, then the universal set will refer to the alphabets. So this is the universal set, all the alphabets for the vowels. The same way, if you have the set of consonants, then the universal set will be the set of alphabets, the English alphabets. And the complement of a set. The complement of a set A is the set of all elements of U which are not elements of A. So if you have, this is how we denote it, A prime. So this is A complement. If you see something like this, A prime, it means A complement. So you have the set A, we call the vowels, then the complement of A will be the consonants. So we have the universal set, so all the elements of U which are not elements of A. So B is not elements of A, C is not element of A, D is not element of A. So the complement of A complement will be equal to the set of the consonants.